We're going to look at calculating the molar enthalpy using a calorimeter. In our first step, we need to calculate the heat absorbed by a substance. Once we have the heat absorbed, we are going to find the delta H of the system by using the relationship between delta H of the system and negative Q of the surroundings. Then we're going to solve for delta H by dividing by the number of moles to give us our molar enthalpy of a reaction with these units of kilojoules per mole. So here in this reaction, we have 2 liters of potassium sulfate, and we're dissolving 261 grams of barium nitrate into that solution. We make a precipitate immediately, as noted here in the question. And as a precipitate forms, our temperature changes from 26 degrees Celsius to 29.1 degrees Celsius. We're going to calculate the molar enthalpy. So first, we need to find our heat, which is MC delta T. When we're thinking about the mass here, it's easy to think that we use this mass, but this is just of our small sample, and we need to incorporate our entire system. So 2 liters, for every 1 liter, we have 1,000 grams. So this system actually has 2,000 grams, and that's the mass that we're going to use in this equation. We know the specific heat capacity of water is 4.184 joules per gram degrees Celsius, and our change in temperature, or delta T, is 29.1 degrees Celsius minus 26 degrees Celsius. And when we compute that, we're going to get 2.6 times 10 to the 4 joules. And just to help us, we are going to change that to kilojoules. So this is actually 26 kilojoules. In our next step, we are going to change our Q into delta H by applying that delta H is equal to negative Q. When we do that, we get negative 26 kilojoules. Okay, so this is the amount of heat that's being absorbed by the solution, and it's being released by the reaction. Next, we're going to calculate the number of moles of barium nitrate, because that's what we're looking for in this question, the molar enthalpy of barium nitrate. This is when we use 261 grams, and we divide by the molar mass. So if we calculated the molar mass of barium nitrate, we would get 261.35 grams per 1 mole. And that gives us 0.999 moles of barium nitrate. Finally, we can find the molar enthalpy by putting negative 26 kilojoules and dividing by 0.999 moles to get negative 26 kilojoules per mole. This is our answer here.